Solid waste pollution has always been a problem in the Philippines, and one of the factors that contribute to this pollution is the amount of biodegradable wastes in our garbage. In Tuguegarao City alone, a number of local fruit products are sold in stalls found almost everywhere. Vendors just throw the banana and pineapple peelings away without considering the impact they have on our environment. The peelings, together with other wastes, are discarded and collected by garbage collectors of the city government to be thrown in a landfill. While there are garbage collectors, pollution is still a significant problem in the city.
The researchers saw the potential that these peelings have as a source of bioethanol. Ethanol is generated from the metabolic byproducts of fermentation of sugar from yeast. Currently, it is produced from plants or organisms that contain sugar. Bananas and pineapples are abundant in the Philippines and have been known for their high nutritional value. But their peelings have no practical use and add to the volume of trash we produce. The peelings of the fruit is known to contain significant amounts of glucose, a simple sugar that is essential in the fermentation process in ethanol making.
This research aimed to determine if there was any significant difference in commercial ethanol and ethanol produced from banana and pineapple peelings in terms of their flame duration, flame propagation, and flame intensity. The researchers gathered banana peelings and pineapple peelings from vendors along Buntun Highway. They used half a kilogram of banana peelings and half a kilogram of pineapple peelings. The banana and pineapple peelings were cut into small pieces and crushed using a blender. The crushed peelings were added slowly to the water to form a fine mash. Then, 50 milliliters of alpha amylase was added to the mash to help it break down into fermentable sugar. The mash was simmered below 100 degrees Celsius for 30 minutes, and the heat was increased for another 10 minutes to melt the sugar. When cooled, the mash was placed in a container with water and half a cup of yeast was added. The setup was tightly sealed and was left for 6 days for fermentation to take place.
6 days later, the researchers removed the organic compounds using a strainer. The liquid separated from the mixture was distilled to extract the ethanol. Using the rotary evaporator, the 2000 milliliter mixture was heated at 78.5 degrees Celsius, the boiling point of ethanol, allowing the substances with a lower evaporating point to evaporate first. This was repeated 2 times at 1000 milliliters each. After the distillation process, the separated ethanol was collected in an earthenware flask. From the 2000 milliliters fermented liquid of banana pineapple peelings, 151 milliliters of ethanol was produced.
Table 1 shows the data regarding the test done for the flame propagation using banana pineapple peeling ethanol using 5 trials. Table 2 shows the data regarding the test done for flame propagation using commercial ethanol. Among the 5 trials, the minimum flame propagation is 4.26 seconds while the maximum is 8.24 seconds. The mean flame propagation is 5.85 seconds and the standard deviation is 1.59. Table 3 reveals that banana pineapple peeling ethanol has a higher mean than commercial ethanol, with a difference of 2.81 seconds, which says that banana pineapple peeling ethanol has a longer time of flame propagation.
This value means that the difference between the flame propagation of commercial ethanol and banana pineapple peeling ethanol is not statistically significant. The difference between the two means is likely due to chance and not likely due to manipulations. Table 5 shows that among the 5 trials, the minimum flame duration is 36.93 seconds, while the maximum is 59.06 seconds. The mean flame duration is 45.996 seconds, while the standard deviation is 8.11. Table 6 reveals the data regarding the 5 trials done for the flame duration of commercial ethanol.
Table 7 shows that commercial ethanol has a higher mean than banana pineapple peeling ethanol with a difference of 5.37 seconds only. This means that the flame of commercial ethanol lasted for a slightly longer time than the flame of banana pineapple peeling. For Table 8, the computed sig value of 0.785 is greater than 0.05, which says that the difference between commercial ethanol and banana pineapple peeling ethanol in terms of flame duration is not statistically significant. This means the difference between conditions is likely due to chance and not likely due to manipulations. Table 9 shows the flame intensity or color of commercial ethanol and banana pineapple peeling ethanol.
Based on the results and findings of the study, the following conclusion was drawn. There is no significant difference between the ethanol produced from banana and pineapple peelings and the commercial ethanol in terms of their flame propagation, flame duration, and flame intensity.
1. Banana peelings and pineapple peelings are collected instead of adding them into waste discarded into landfills and be used to produce bioethanol. 2. Further research should be conducted as to which fruit peelings produce more bioethanol. 3. Further research should be conducted for large-scale production of bioethanol in the locality to help solve the problem of expensive fuel.
Based on these results, we can conclude that banana and pineapple peelings are potential sources of bioethanol.